Hello and welcome to the Unit 5 videos for geometry, and this is about similarity transformations, okay? And the first thing we're going to talk about today are dilations. Now, before we talk about dilations, what I want to talk about is this word similarity, okay? The word similarity, okay, that means proportion, proportional, okay? And that means the same shape. Okay, so the same shape, but different size, okay? Okay, so what I want to do is come over here and say that, a dilation is where you take an object and you either make it bigger or smaller, okay? So a dilation is where you make a figure bigger or smaller. But you keep the shape, okay? And so here's what we've got. It says a dilation about point Q of a scale factor of n is a transformation of the plane where each point P of the plane is assigned a new point such that the length of QP is equal to n, or Q times P prime is equal to n times Q times P. Okay, a lot of crap there, okay? But Q is the center of the dilation, and n is the scale factor. Now, before we go on, okay, if I know that n is larger than 1, that means that the figure gets bigger, so that we get bigger, okay? And I know if n is between 0 and 1, so if n is a fraction, that means that we get smaller, so we get smaller. Okay. And so, all right, let's just kind of take a look at some stuff. So the properties of dilations. A dilation is that it preserves angle measures, things being parallel. So BA is parallel to A prime, B prime. Points are collinear, and the orientation of the segments. And it creates proportional side lengths, okay? So we also talked about the scale factor of n. Okay, we'll determine whether the dilation is a reduction or an enlargement. So reduction, meaning it gets smaller, okay, that means that n is between 0 and 1, okay? So that means that n is a fraction, okay? And we all know about fractions. They my friend, we having a good time, okay? An enlargement means that your scale factor n is greater than 1, okay? And that means that it gets bigger, okay? So that's what we're looking at, all right? And you can kind of tell here is that, if you look at this here, the point xy, or the line xy, is your original, okay? It's your OG, original, okay? And then this x prime, y prime, this line, after you've dilated it about point C, is your image. Okay? Same thing over here. Now remember, look how, xy, because your scale factor, it's a reduction, your image got smaller. That's because n is a fraction. N is between 0 and 1. Okay? Over here, all right, n is greater than 1. You started here. Here's your OG. SU is your OG1. Okay? It's your OG. All right, your original. And then your image is bigger, okay? And it was increased by a scale factor by something larger than 1. Okay, so then it says this, okay? What I know is that we want to enlarge this segment. So what I want to do is I want to dilate segment AB, okay, with the center at point C by a scale factor of 2, okay? Now here's what happens here. All right. The distance from point A to point C is a distance of 2. Okay. Now the thing of it is that I want to increase this by a scale factor of 2. So I know that n is equal to 2, and I know that 2 is larger than 1, so it's going to get bigger. Okay. And so if I were to take this distance of 2 and multiply this distance by 2, that would give me another distance of 2, okay? So that means that the whole thing is going to be 4, okay? And then I'm going to double this distance here, which is a distance of 3, by another distance of 3. Okay? And what happens is I get this value of A prime, B prime. All right? So I have this point here and have this point down here. All right? And what happens is if I take that here, what I notice is that AB is twice as big, or A prime B prime is twice as big as AB. Okay? And I also know that these are parallel. Okay? I know they're parallel. So I can say this, that if I take, I know A prime, segment A prime B prime is equal to 2 times the segment of AB. Okay? And that's that. All right, now let's talk about a dilation of lines. Okay? So what I know is that a dilation moves each point of the figure, other than the center of the dilation, a specific distance based on the values of n, where n is greater than 0. Okay? So what I know is that, if I were to take, this point here, x prime and x are going to be points on the same line. Okay? They're collinear. Okay? Same thing with z and z prime. Okay, they're going to be collinear, and you're going to get parallel lines created from that. Okay, so kind of some things we've already talked about. We have talked about dilations, just not, just we're talking a little bit more in depth and in detail. Because all these scale factors are going to come back. This n value is going to come back later when we talk more about similarity. Okay, let's look at the next page. And what we want to talk about, and in the other page, we talked about enlargement of segments. Let's talk about the reduction of segments. And so what we have is we have the segment AB, the pre-image, the OG image, is dilated to produce the image A prime B prime. So this gets smaller. Okay, notice how this is a lot bigger than this. All right. Now what I know is that this distance here from C to B is a total distance of 4. Okay, so I know this, that CB, if I take CB, is a distance of 4, okay? And if I take CB prime, okay, that is a distance of 1, okay? Now, because we're getting smaller, I got to think about, all right, well, how do I use these numbers here? What do I need to do? And so, because I'm smaller, I know that n, my value, my scale factor, n, needs to be between 0 and 1. So how could I use the numbers 4 and 1 to make a value that's smaller? And so my value for n would then be 1/4. Okay? Now let's do the same thing over here. What I want to do is I want to take A prime C and then AC and see what we get there. Now if I take the number 5 and divide it by, or 1.25 and divide it by 5, okay, if I do that, if I take 1.25 and divide that number by 5, then that's also going to give me 0.25, which is the same value as 1/4. Okay, so your scale factor is 1/4. All right, but you have to use the side lengths to create a fraction that gives you that value. All right, so now let's take a look. Let's see if trapezoid A prime, B prime, C prime, D prime is a dilation from A, B, C, D, okay? And what I'm going to do, is kind of take a look at a picture over here and see and determine, are they proportional, okay? Now, what I know is this. If I were to take 3 and divide it by 1, okay, or let's take 1 and divide it by 3, okay, because we're dealing, because this is smaller. My image is smaller than my original. So this is a reduction. Okay. So my value for n, let's think of how we could use these numbers 1 and 3 using division. Okay. So one thing I know is this, is that 1/3, if I were to take 1 and divide it by 3, okay, let's also do the same thing over here. Let's take this segment, which is D prime C prime, and compare it to DC. All right. And that value, n, would be 2/6. If I simplify that one, it's going to give me 1/3, okay? And that's my value for n. Now, the other thing I could do is take these numbers 3.75 and 1.25, the distances from these points to q. So from A to q and then from A prime to q. If I were to take 1.25 and divide it by 3.75, that would also give me a value of 1/3. Okay, and if you're trying to figure this out in the calculator, just do 1 divided by 3. Okay, 1 divided by 3 gives you 0.3 repeating. Okay, then do the same thing here. Do 1.25 and divide it by 3.75, and that will also give you 0.3 repeating. All right. Now, same thing over here. If I were to take 1 and divide it by 3 here, it would also give me 1/3. So yes, they're proportional. Proportional. Okay? And so it is a dilation. So it is a dilation. Is a dilation. Okay, here's what I know. Okay, figures that are not dilations. So what I could do is I could do this. I could say, if I were to look at, say, like L prime P prime is 8, and LP is 24, let's take that. Let's make a fraction out of that. Let's say, okay, let's let N equal 8 divided by 24. And the question is this equal to doing the same thing with these sides of P prime, N prime, and Pn? Is that the same thing as 5/20ths? Okay. Now, there's a couple different ways of doing this, but just kind of think about the fractions here. Okay, if I were to take 8 and divide it by 24, each of these numbers are divisible by 8. All right. And so this would end up giving me N is equal to 1/3. Okay. And is this equal to 5/20ths? Okay, well, if I simplified that, okay, 5 divided by 5 and 20 can be divided by 5. This would give me 1/4. Okay, are these two fractions equal? And the answer is no, they're not equal. Okay, so that means that they're not dilations. So that they're not, it's not a dilation. Okay, that means that they're also not proportional. Proportional. Okay, and same thing over here. Okay, if we were to look over here and say, all right, well, what's going on here? And are these two also proportional? Notice how C and C prime are not on the same line, okay, from that center of dilation. And notice that the angles are congruent. Remember that proportional figures, or dilations, preserve angle measures, okay? Angles are congruent. So, 67 degrees is not equal to 72 degrees, so they are not dilations. Not a dilation. Okay, that means that they're not proportional. Proportional. Okay, so that's it. That's kind of what we're dealing with here. So use fractions, use these ideas. I know it's kind of boring. Hey, guys, I'm having a great time. Hope you are too. We'll see you on the flip side. You guys doing a great job.